Hello, Fundamental Theorem of Algebra here. We are going to be discussing polynomials. So the Fundamental Theorem of Algebra states that a polynomial with a degree greater than or equal to 1 has at least one root. It may be complex. It doesn't necessarily need to be a rational root. If you have a polynomial with degree n, you will have n roots. Okay, that is the Fundamental Theorem of Algebra. Now let's talk about the rational root theorem. So if you have a polynomial that is in standard form with integer coefficients, such as we do right here, the leading coefficient will be q, so the leading coefficient would be 1, my q value would be 1, and your constant is your p on the back end. The constant would be -4. This constant cannot be 0 for the rational root theorem to hold. So a list of all the possible, not necessarily all your roots, but all the possible rational roots of the polynomial are the positive and negative combinations of the factors of p over q. Okay, it might seem complex, but once we start putting it into action, it really isn't too super difficult. So first things first, what I do is I'm going to take p on the back end, and I'm going to list the factors of this 4 value. So 1 times 4 is 4. We also have 2 times 2, so that is a list of all my factors of p. Now we are going to list the factors of q, which are my coefficient. The coefficient is 1 right here, so the factors of 1 would simply be 1. Now it is all the possible combinations here. So first I'm going to start with this 1 value up top. 1 over 1 would give me a possible root of 1. 2 over 1 would give me a possible root of 2 or -2. 4 over 1 gives me 4. That is a list of all the possible rational roots of this polynomial right here. So you have a list of all the possibilities. You now need to check these possibilities to see which ones work. The easiest and most efficient way of doing that, other than punching it to a computer and immediately getting your roots, would be to use synthetic division. Since these are roots right here, we could come in, let's say we wanted to start with checking a value of positive 1. 1, let's do my synthetic division. So the coefficients for my polynomial, I get 1, 1, -4, and -4. Once we get a remainder of 0 here, we will know that we have found a root. So I bring down my 1, now I multiply. Bring it down with addition, 2, multiply. Bring it down, -2, multiply, -6. That's a remainder, therefore 1 is not a root. So then let's jump to -1 and give that a whirl. Coefficients 1, 1, -4, -4. Multiply. -1, add down, multiply. Add down, multiply, and we get 4 there with a remainder of 0. Fantastic. Okay, that looks pretty cool. I'm kind of liking that right there. Let's see what happens. We were at a degree 3 and we divided into, so that means we are now going to be dropping down a degree. If that was degree 3, this will be the coefficient of degree 2 plus 0x minus 4. So my new polynomial that I have, I would then be looking at x squared minus 4. X squared plus 0x minus 4. Okay, we could solve this to find my remaining 2 factors. My 2 factors here would be x plus 4, x plus 2, x minus 2. Well, if you were to take these 2 factors and change them into roots, change them into zeros, we would be getting x equals -2 and x equals +2. So coupling that up with my other root that I found of -1, if we were to list all the roots of this, we would be looking at x equals -1, -2, and a +2 for my 3 roots, my 3 zeros of this polynomial function. All right, let's take a look at another example. Say we have g of x equals 2x to the 4th plus 5x cubed minus 8x squared minus 17x minus 6. If we were to want to find all of my roots here, we could do that by using the rational root theorem. So we will take all the factors of p which are on the back end. So all the factors of that 6, 1 times 6, 2 times 3, and that would be all of them, over the factors of q. Q is my leading coefficient, so the factors of 2 would be 1 times 2. It is the positive and negative of all of these combinations. So first I will start with 1. 1 over 1 gives me a value of 1. Then it is 1 over 2. 1/2. Now we will do 2 over 1, which gives me 2. And then 2 over 2, which gives me 1. We already have 1 listed, no sense in listing that again. 3 over 1 is 3. 3 over 2, 3/2. 6 over 1 is 6. 6 over 2 is 3, which we already have listed. There is a list of all the possible rational roots of my polynomial. Now it just comes down to a little bit of guess and check. You can really start wherever you would like. How about we start with, let's say, 1/2. Can use synthetic division with fractions just as long as you are dividing by a binomial or you already have the root. 2, 5, -8, -17, and 6. 2 comes down, half of 2 is 1. Add down 6. Half of 6 would be 3. Add down -5. Half of -5, -5 halves. When we do this math here, we're going to be looking at a little over 17, 18. Half of 18 will not be -6 right there. So we will end up with some sort of remainder. I don't even really care what that remainder is. The fact of the matter is it's not 0, so I know that 1/2 is not one of my roots. We could try a -1/2. 2, 5, -8, -17, and 6. Bring down the 2. -half of 2 would be -1. Add down 4. -half times 4, -2. Add down -10. That would give me a 5. Coming down, we get -12, giving me a positive 6. Oh, excuse me. Whoop, forgot that negative right there. Coming down, we do end up with a remainder of 0. All right, interesting. That looks good to me. So now we were at degree 4. We are now dealing with degree 3. 2x cubed plus 4x squared minus 10x minus 12. All right. I know that I have one of my roots. It is -1/2 right there. One of my zeros, one of my roots, -1/2. We have found one because we have a remainder of 0. Well, now we have been brought down a single degree. We are now dealing with 2x cubed plus 4x squared plus 10x minus 12. Now we are doing PQ again. We are going to continue on our little path here. We could factor a 2 out of this to make it a little bit more streamlined, to make our numbers smaller. Won't really matter either way though. So let's say I now jump and I try a value of 2 as my root. Is 2 a root? Well, we can check this out. I will take my coefficients, 2, 4, -10, and -12. Slide down the 2, multiply. Add down, multiply. Add down, multiply. Oh wow, score! I found another root. We have a remainder of 0. 2 would be a root. 2 is a 0 for us. So we were at degree 3. We need to drop this down a single degree. So now this will have an exponent of 2. 2x squared plus 8x plus 6. And that is a quadratic. That can be factored. That can be solved. We can now deal with that. So looking at that, I will pull out a 2, and then I will get x squared plus 4x plus 3. The factors of this, 2 times x plus 3 times x plus 1. These two factors will result in 2 more zeros, 2 more roots. This would give me x equals -3 and x equals -1. If I take my previous 2 roots that I have found of 2 and -1/2, you have found the 4 roots of our polynomial. I think we should do one more example right here, and then we'll be finished for the day. How about k of x equals x cubed minus 4x squared plus 6x minus 4. All right, we're going to take the factors of the back end, that coefficient, over the factors of the front end right there. All right, so the factors of the back are my p-values, 1 times 4, 2 times 2 over the factors of q, which would be 1. So positive and -1, positive and -2, positive and -4. Those are all the possible rational roots. So let's just say that we start with, I don't know, you pick anything you want, positive and negative. I don't know, we could go with a 4. So the coefficients, 1, -4, 6, -4. Bring down the 1, multiply. 0, multiply. 24, that's going to be some remainder. I don't even really care what it is. I know that 4 is not one of my roots. As long as I have a remainder, it's irrelevant what that remainder is for our purposes here. I don't know, let's try 2. Pretty much what you just need to ask yourself is if you're feeling lucky. Are you? Bring down my 1. 2 times 1 is 2. Add down -2. Multiply. -4. Add down 2. Multiply 4. Wow. I am feeling lucky. So I have my exponent of 3. I bring it down a degree because I've factored into it. So now this will have a leading coefficient that has degree 2. So this would be 1x squared minus 2x plus 2. Okay, I'm looking at that. I wanted to find the factors of 2 that combine to give me -2. That doesn't really work right there. So we're going to need to fall back on the quadratic formula. All right, so my a value equals 1, my b value equals -2, and my c value equals 2. There's a little refresher on your quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Break it up into 3 pieces here, please. Will be most convenient. So first, let's do -b. Well, b is -2. -2 times a negative would be +2. Leave that blank, and then let's do 2a down on the bottom. Well, 2 times a would be 2. Now as a little side work, let's do b squared minus 4ac. Okay, b squared, -2 squared is 4. Minus 4, and then let's do a times c. Well, a times c would be 2. So really inside is 4 minus 8, which is -4. Pretty streamlined way of dealing with that quadratic formula right there. Thank you, Mr. Williams. All right. Let's clean it up. Let's simplify this thing. So x equals 2 plus or minus, this would be 2i over 2. It's all over 2, so this part is over 2 and this part is over 2. That might help you reduce. X equals 1 plus or minus I. Those are your other 2 roots. We've found one previously up top here with my remainder of 0. So our roots for this polynomial would be x equals 1 plus I, x equals 1 minus I, and x equals 2. Rational roots, fundamental theorem of algebra, emphasizing the fun in the fundamental. Thank you.